In this video, I will be discussing the conversions which are involved in alcohol phenol. Okay, so the first conversion is ethanol to methanol. You draw the structures of what you are converting and into what. So you are converting basically ethanol to methanol. You are decreasing carbon atom. So when you are decreasing the carbon atom, you have to think of such reaction also in between where you are decreasing carbon atoms, right? So first what we can do is, we can oxidize this ethyl alcohol in the presence of potassium permanganate acidified, which is a strong oxidizing agent, and it will result in the formation of acetic acid. So acid is formed. Thereafter we can treat this acid with sodium, which is acidic in nature, so it will definitely form the sodium salt of the acetic acid. Now we want to decrease carbon atom, so you can follow decarboxylation. It is the reaction which you people studied in class 11. That is reaction with soda lime, caustic soda and lime. So what will happen? Na2CO3 will come out and you will be left over with methane. Methane is obtained. Now methane, you can prepare methyl chloride by treating this with chlorine, limited quantity of chlorine in the presence of sunlight. And just the last step now, replace this Cl by OH, that is treat this with KOH. Aqueous KOH will solve the purpose, not alcoholic. It has to be aqueous. Anyway, alcoholic also will not do anything in this because there is only one carbon atom. Now meth to eth means we are increasing the carbon atom. Methanol, you are preparing ethanol from it. From methanol you are preparing ethanol. One carbon increase. So when you are increasing carbon atom, think of cyanides. So what you can do is, first treat methanol with thionyl chloride. So you will get one chlorine in this. Treat this with potassium cyanide, ethanolic potassium cyanide, alcoholic potassium cyanide. You will get one carbon more, that is cyanide you are going to get. Cyanides to acid is very simple. You can hydrolyze this cyanides in the presence of acid medium. React with water in the acid medium, you can prepare acid. From acid you can prepare same number of carbon atom alcohol by using a reducing agent. So lithium aluminium hydride is a good reducing agent which can reduce acid to alcohol. So you will be getting the same number carbon atom alcohol, right? So these are the two conversions. You can please note down the conversions in your notebook and practice them. Try to do on your own, then only you will gain confidence. Okay. Yeah, moving on to the next conversion, which says ethanol to isopropyl alcohol. Ethanol, 2 carbon alcohol. You are preparing isopropyl alcohol. Isopropyl means at 2 carbon you have OH and the total number of carbon atoms are 3. Right. So what you can do is, there might be some other ways, but I am telling you one of the way. You can first oxidize this in the presence of CrO3. Prepare acetaldehyde, CH3CHO. CrO3 will oxidize primary alcohols to the aldehyde. It will stop at aldehyde. Now we want one carbon atom more. So what you can do is, treat this aldehyde with Grignard reagent, CH3MgBr. You remember we have done, if you use any other aldehyde with Grignard reagent followed by hydrolysis, you will get 2 degree alcohol. So in the first go, CH3, CH, here you will have the CH3 of the Grignard reagent, and this side you will have OMgBr, that is added on product, and then finally you have to carry out the hydrolysis in the acid medium. That means this bond will break here, H and OH. That means you will get isopropyl alcohol. Right? Now methane, that is formaldehyde to ethanol, means one carbon increase. Remember, always whenever we are using aldehydes, we are preparing alcohol, we will think of Grignard reagent. We are having more carbon atom. The Grignard reagent is mainly used for ascending the ascending the series, increasing the carbon atom. So it is methanol. Formaldehyde is methanol. You want one carbon more. You want to prepare eth. So you will be using Grignard reagent, CH3MgBr. So this will add here, Mg will add on here. So what you will have is this H as such, CH3 on the top, O, MgBr, and then followed by hydrolysis. So when you carry out the reaction with water in the acid medium, the H will be here, OH will be here. That means the main product what you're getting is this. This is the product you were looking for. And apart from that MgOH, that is of course the side product which you're getting. Clear? So many of the reactions are involving Grignard reagent in this. Okay. Moving on to the next one, acetone to ethyl alcohol. You want one carbon less. So what we can do is acetone, CH3COCH3. Okay, you can first oxidize it in the presence of KMNO4, acidified. Acidified KMNO4, when we are carrying out the oxidation, this has to be at high temperature. So this bond will break. You will get 2 carbon acid also. That is acetic acid you will be getting. And from acetic acid, what you want is same number of carbon atom alcohol. That means you are basically reducing it. Ethyl alcohol can be prepared by using lithium aluminium hydride. So 1 carbon atom you are decreasing. So this can be done. First you oxidize acetone to acid, and then acid say reduction you have to carry out, you can get alcohol. Now methanol to isopropyl. Methanol. What is methanol? CH3OH. What you are preparing? CH3CHO, this one. Okay. So what you will do is, first you treat this with thionyl chloride. You have to increase 2 carbon atom. So think of Grignard reagent also. You will get this in the first go. Right? Then what you do is, you can treat this with potassium cyanide. Increase the carbon atom. What you get is acid. From acid, you can reduce it. LiAlH4. You will get 2 carbon alcohol. 2 carbon alcohol. After this 2 carbon alcohol, that is you got ethyl alcohol, you have to prepare isopropyl. So here onwards, the steps will be like this one. First, from methanol, what you do is, from methanol you prepare ethyl alcohol by this method. After you get ethyl alcohol, you can follow this technique. That is ethyl alcohol oxidized to form aldehyde. Then aldehyde say add Grignard reagent, you will get isopropyl. So I hope this method is also clear. Yeah, moving on to the next conversion, isobutyl alcohol to tertiary butyl. Now what is isobutyl? You have this and OH. You are preparing tertiary butyl alcohol. Tertiary butyl means you are getting OH here. So first what you do is, you can remove water from it. So in the presence of concentrated sulfuric acid, you can remove water, and so what you get is this OH from here, H from here, you will get a double bond. This is carbon. You will get this. And then from here it is just one step. You have to hydrate it in the acid medium. You want H here and OH here. That's what you were looking for. Remove water, bisulfuric, add water. Acetylene to ethanol. Okay. So first you take ethine. You treat with water in the acid medium. You will get first water added on. It's a symmetrical one, so no issues at all. Vinyl alcohol first. which will undergo tautomerism and will result in the formation of acetaldehyde. This H goes here, double bond comes, you'll get acetaldehyde. From acetaldehyde, you can prepare ethyl alcohol. You are not increasing the carbon atom, so you do not think of Grignard reagent here. Just you are using LiAlH4. If not, simple catalytic hydrogenation also will do. Nickel, platinum, palladium and hydrogen. Right? The next one. From propene, you are preparing propane 1-ol. Propene. This is H, double bond CH2. You want OH on first carbon atom. You want at first carbon means you have to think of anti-Markovnikov. You will add on HBr in the presence of peroxide to propene, which is unsymmetrical alkene. So you will get Br at the end, and just one step now, treat with aqueous KOH or aqueous NaOH. So OH will come here. Suppose you want here 2 position OH, then you will just use HBr in that case, not peroxide. Because we used HBr, it added on as per anti-Markovnikov. Had it been just HBr, then as per Markovnikov, Br would have been here, and then aqueous KOH would have given you 2 position OH. Benzene to benzyl alcohol. Benzene, you want to prepare benzyl alcohol. Benzyl alcohol is this. So first thing is we need to add on carbon atom on the side. So you can carry out its Friedel-Crafts reaction. Anhydrous aluminium chloride and methyl chloride. You first get toluene from it. This is toluene. Then on this toluene, we want some chlorine. So react with chlorine in the presence of sunlight. That is side chain halogenation we were looking for. So you will get this. From here it is just one step. Treat with aqueous NaOH or KOH. So Cl will be replaced by OH. Clear? Now, normal propyl alcohol to isopropyl. We want from normal, we want to prepare iso. That's a similar thing like as I told you earlier. What you do is first you treat this with concentrated sulfuric acid, remove water, you get a double bond, and now you want a 2 position, right? So you will just add on HBr without anti-Markovnikov. You will get Br at the center carbon, and now just you have to treat with aqueous NaOH or KOH. If you want at 1 position, then we have to think of anti-Markovnikov. Or one more thing, this reaction which we discussed, propene to propane 1-ol, you could have directly carried out hydroboration oxidation. Then too you get as per anti-Markovnikov addition, water molecule. Okay, so here you could have done just directly also, no need for peroxide, right? Yes. So the last conversion in this video, isopropyl alcohol. Isopropyl is this. What you want to prepare is, you want to prepare tertiary butyl alcohol. So we want to increase carbon atom. Do not forget Grignard reagent. But for that, alcohol will not give. It is only ketone or aldehyde will give. So you oxidize it first. In the presence of chromium oxide, you can oxidize this, and what you can prepare is acetone. You can prepare acetone. And then on acetone, you can just add Grignard reagent. So CH3 will add here, Mg will add on here. So what you get? CH3 on the top, and on O you have MgBr added on. And then just the last step, you have to carry out hydrolysis in the acid medium HNOH. So isopropyl is converted to tertiary butyl alcohol. Okay, there may be many more conversions in alcohols which can be discussed, but those we are going to discuss only after we complete aldehyde ketone and carboxylic acid, because more conversions will come from then onwards, because all organic chapters are interrelated. So as of now you can practice these conversions, and I think these should be helpful. Thank you.